All right, boys and girls, today we're doing Module 3, Lesson 14, and we are going to take notes first. So you need your math notebook. Remember, at any time, you can pause the video and go back if you need to so that you can catch up on your notes. Okay, so we're still working on word problems and multiplication. So I want to take some notes about how we know in a word problem if it's a multiplication problem. So some things we've been noticing about multiplication is that it will say 3 times as many. Many of our word problems say this. So this is the clue that it's multiplication. So I'm going to write this up here, multiplication. So these are just clues that it would be a multiplication style of problem. Also, another thing you might see is you'll see the final question might ask, well, how many of whatever they're talking about, socks or marbles or cards, it will ask how many. So how many sometimes is the clue as it could be a multiplication problem. It doesn't have to be, but if you see 3 times as many and then it asks you, well, how many? You know that you're probably solving multiplication. This whole module so far has focused on multiplication. Now we are moving also into division though. So it doesn't mean that every problem will be multiplication. It could also be division. And many of the problems so far have been more than one step. It's been 2 or more steps. So it's not always just multiplication. It could also include adding or subtracting. So some of the other things we've seen in our word problems is one part of your word problem might be multiplication. It actually might ask you like 3 times or 2 times as many, and that's the clue as multiplication. But then it might say like 100 fewer than. So another part of the word problem might say 100 fewer than. So this is not multiplication. This part of the word problem, when we said the word fewer, that means less. So that actually means you're subtracting. So when you see fewer, that's subtraction. So I'm going to write subtraction. So words like fewer or less than, you're comparing, but it means it's a subtraction problem. So this word fewer is the same as less. Something else we've seen in our word problems is we've seen maybe 59 more than in the second part of the word problem. Well, more means we're adding. So that would mean that whatever you figured out in the first step, the second step would be an addition problem. Okay, so those are just some key words that help you decide if you need to multiply, if you need to subtract, or if you need to add. Because in a word problem, that's usually what you're asking yourself. You're asking yourself, well, am I adding? Am I subtracting these numbers? Am I multiplying or am I dividing? And in many of our problems so far, they've been 2 steps. You're doing 2 of these things. So far in our problems, you've been multiplying is usually the first step, and then either adding or subtracting is the second. So this is what we've been doing so far. We've been focusing on these 3 operations, and usually 2 of them are included in your word problem. Okay, so now we're going to actually take a look at your workbook. All right, so we're on page 87 of our Module 3 workbook, and we're going to do the application problem because this is exactly an example of what I just went over in our notes, where it's going to be more than one step. One part of the problem will probably be multiplication, and then the other might be adding or subtracting or something like that. So we're going to read it and decide. And remember, we're doing the read the problem, draw the problem, and then write equations to solve it. So it says, Tyler planted potatoes, oats, and corn. So he's planted 3 items. He planted 23 acres of potatoes. All right, so we actually know how many acres of potatoes he planted. So I'm going to write P for potatoes, and I'm going to write this number 23 acres. 23 acres. So we know one part of this problem. We know his potatoes. He planted 3 times as many acres of oats as potatoes. So before I move to the next part of the sentence, I noticed that for oats, so we're talking about oats, it's 3 times as much as the potatoes. So I know how many potatoes, and we know that 3 times means multiply. So it's going to be 23 times 3. That will give me my answer for how many acres of oats. And then I'm going to read this next part. And he planted 4 times as many acres of corn as oats. Okay, so corn. So 4 times, I'm actually going to write that first. 4 times as many acres of corn as oats. I don't know the answer for oats yet. So I'm going to put an O for oats because I got to solve this first. All right, then I need to read my last part before I solve any of this to see what my final answer needs to be. How many acres did Tyler plant with potatoes, oats, and corn in all? When I see a word like in all, this kind of gives me the clue that the second step of my problem, or the final step, is probably addition. So I'm going to have to add the potatoes, the oats, and the corn when I'm all done. So in all means I'm including all these items, which means I'm adding it all together. So I know how much potatoes we have. So the P I already have. The oats I have to solve first. And then once I have the oats, I can solve corn. So I'm going to go ahead and multiply 23 times 3. We know how to solve using the standard algorithm. So I'm going to do the 3 times 3 is 9. So I'm doing my ones first. Then I'm going to do 3 times 2 tens. That's 6 tens. Okay, so I know there's 69 acres of oats. So there's my answer for oats. But I'm not done. I now need to find corn, and it's 4 times oats, which is 4 times 69. So I found oats. That filled in the O for oats. So this was originally my missing variable or my missing number, but I now know that missing number because we solved for oats. Okay, so I'm going to solve this one, 69 times 4. This one requires regrouping. So this multiplication problem didn't. This one is going to require some regrouping. So 9 times 4 is 36. I can't just stick my 36 down here. So I'm going to regroup the 3 for the 30. So that's my 3 tens and my 6. Okay, so I added my 3 tens over to the tens. Now 4 times 6 tens is 24. 4 times 6 is 24. But plus 3 more tens is 27. So I'm just going to bring my 27 down here because I don't have a hundreds place to regroup it to. So 276 acres of oats. So now I have both my oats and my corn, but I also had my potatoes. So now I'm going to add potatoes, oats, and corn in all. So my final step of this problem is adding up these 3 numbers. All right, so I'm going to put the largest number on top. That will be easier. The largest number in this case is corn. So I'm going to do 276 plus, so I might even want to circle these numbers so I know what numbers I'm adding because I have a lot of calculations here. So 276 for the corn, 69 acres for the oats, and 23 acres for the potatoes. If it's too challenging to add the 3 numbers together, you could do 2 and then do the final one. So let's see, I know that 6 and 3 is 12, and 12 and 6 is 18. If you know your multiples of 6, that wouldn't have been too difficult. I know that 7 and 2 is 9, plus 1 more is 10, and 10 plus 6 is 16. So notice how I saw some facts that I knew to kind of make it 10. 7, 1, and 2 is 10, and 6 is 16, so 10 and 6 is 16. Carry the 1, bring down the 6. 2 plus 1 more is 3, so 368 acres of potatoes, oats, and corn. Okay, so make sure you have that written down. This is the final answer, so I might want to put a big box around it because I have a lot of other numbers on my paper, and I want to make sure that I can see your final answer. Remember, at any time you can pause the video and to take your notes. Okay, so we're going to switch back over to our notebook. We're going to continue on the same page where we left off. We did the application problem for lesson 14, and we had some notes about how we know when it's a multiplication. But this is the thing, we're going to start moving into the operation of division. So we've been working primarily with multiplication, adding, and subtracting, but we're working now on division. So I want to just put some notes in here about what division is. So division is the opposite or inverse operation. So division is the opposite or inverse, so this is an important word, operation of multiplication. All right, so I'll give you a second. Remember, you can always pause at any time if you need to pause to write this down. So what I mean by that is that just like subtraction and addition are the opposite of each other, like just to give you an example using addition and subtraction, let's do this 3 here. I can say 5 plus 3 equals 8, and 8 minus 5 equals 3. So these are basically fact families. So I could say 5 plus 3 is 8, 3 plus 5 is 8, 8 take away 5 is 3, or I could say 8 take away 3 equals 5. So they're kind of like fact families. So when I'm talking about divisions, the opposite or inverse operation of multiplication, it kind of works the same way that addition and subtraction work together. So just as an example, I know that 2 times 6 equals 12. So just kind of using a multiple of 2 for an example. Well, in the same way, I know that 2 times 6 is 12 and 6 times 2 is 12, because remember with multiplication, you can use the commutative property. I know that with division, 12 divided by 6 equals 2, and 12 divided by 2 equals 6. Now, the one thing I do want to point out is that with division, just like with subtraction, it is not commutative. I cannot do 6 divided by 12. It comes out to a totally different answer. So I want to kind of put a box around the division here and put not commutative, meaning I cannot switch the 6 and the 12. I cannot switch the 2 and the 12. Because 2 divided by 12, totally different answer than my answer of 6. 6 divided by 12, totally different answer than my answer of 2. I cannot switch these and still get the same answer. Unlike multiplication, it doesn't matter if I do 2 times 6 or 6 times 2. This is commutative, this is not commutative. So when we're dividing, you do need to make sure that you're starting with the total amount and then dividing it into smaller groups. So with the division we're working on right now, your number or let's see, your dividend is going to be the largest number that you're going to be starting with, and you'll divide it into smaller groups. So there's some words that I kind of want to work on, and I'm running out of room on this page, so I'm going to turn my paper. You might need to do the same. Remember, at any time you can pause and take notes to keep going. All right, so I turned my page. I'm still on module 3, lesson 14, but I'm continuing, and I'm continuing with division. So on the other page, we wrote that division is the opposite or inverse of multiplication. So with multiplication, it's repeated addition. With division, it's not repeated addition, it's basically repeated subtraction. So I'm going to write that down. It's repeated subtraction. With multiplication, you're counting the same number of groups over and over again. With division, you're separating a number into equal groups. So we can think of it as repeated subtraction, or we can think of it as separating a number. So we're separating a number into equal groups. Okay. So that's what division is. This kind of, again, is the opposite of multiplication. So just as an example, I'll use kind of some smaller numbers so that we can draw a picture of it. If I have the number 15 and I'm going to divide it by 3, 15 divided by 3, I'm taking 15 and I'm dividing it into 3 equal groups. So I might know what the answer is because if I know my multiplication really well, I know the fact family for this. I could draw a picture. So I want to divide this number 15 into 3 equal groups. So here's 1 group, 2 group, 3 group. I need the same number in each group. So if I have the number 15, I might go 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15. Okay, so I took 15 and I divided it equally into 3 groups. And then I look and see, well, what's inside each group? Well, there's 5 inside each group. Each group got 5, so my answer is 5. And if I know my multiplication really well, I also know, so this is my little thought bubble, I know that 3 times 5 equals 15. So this missing number, because I already had the 3 and I had the 15, the missing number was 5. So if you know your multiplication, these types of division problems are not that challenging. If you need a little help, you can draw a picture to help you. And in the word problems we're going to be solving here in a moment, pictures are going to help us because it'll help us visualize exactly what kind of problem it is and how we're going to separate it. All right, so we're moving back to our workbook. We're now on page 89, so you just had to turn the page to where we were working a moment ago. So we're kind of going back between our notebook and our workbook. So now we're back in module 3 in our workbook. We're only going to do question 1, and then tomorrow we'll do some of these problems together. So we're going to use the read, draw, and write to help us solve these problems. So let's take a look at number 1. There are 19 identical socks and many pairs of socks. Oh, how many pairs of socks are there? So remember, a pair means 2, just like when you grab socks out of your drawer, you need 2 for your 2 feet. All right, will there be any socks without a match? If so, how many? Okay, so the first question that's asking you is how many pairs of socks are there? They're telling you there's 19 individual socks. So I'm just going to draw little sticks to show the 19. So I'm going to show 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I drew 19 sticks just to represent all the 19 individual socks. I know that it's asking me about pairs. So that means I have to circle groups of 2. So I'm going to circle groups of 2 to show a pair. So here's a pair. Here's a pair. There's 2, 3, 4. So I'm circling groups of 2 because obviously 2 socks equal a pair. So I'm at 6, 7, 8, 9. Oh, look, there's a sock left over. It doesn't have a pair. I'm not going to circle that. I'm just circling pairs right now. So this picture, I'm going to write a number sentence to go along with it. So I had 19 individual socks. I had to group them in groups of 2, basically. So I'm going to say divided by 2 because I had to put them in pairs. How many pairs do I have? Well, I can count here. 1, 2, 3, 4, 5, 6, 7, 8. I have 9, and I have 1 left over. When you have something left over with division, it's called a remainder. So I'm going to put remainder 1. So there's my number 1. So I had 9 pairs of socks, but I had 1 little sock left over. So when I have something left over in division, the word for that is remainder. Okay, so look, I've already answered the first question. I have 9 pairs. So here's the first question. And now I need to look at my next one. Will there be any socks without a match? Well, yes, there's 1 sock without a match. So 1 left over. And then I think we already answered the last question too. Well, how many? Well, we have 1 left over. So there's 9 pairs and 1 left over sock. I'm gonna write the word socks. Remember, we're talking about socks. So our number sentence was 19 divided by 2. It gave us the 9 pairs with a remainder of 1 or 1 leftover sock. So we read the problem, we drew out the problem, and then we even wrote a number sentence to go along with it. So remember, at any point you can pause and stop the video so you can take your notes.